With this video, I just want to review this little chart that we've seen before, similar to the ARRT content specifications. And the factors on the left we're going to increase and see how they affect the quality factors on the right columns. And so first of all, if we look at receptor exposure, what we mean by receptor exposure is simply the total number of X-ray photons striking the image receptor, typically. And so any increase in MA in exposure time will increase that proportionally, and KVP will increase that by the 15% rule, so all those factors increase the receptor exposure. SID, as it increases, the receptor exposure goes down by the inverse square law. So if you double the SID, you'd have 1/4 the amount of receptor exposure. Grid ratio, as the grid ratio increases, more X-rays are blocked from the receptor, and so that decreases receptor exposure. And grid cutoff absorbs primary radiation, decreasing receptor exposure. Tube filtration inserting aluminum would take away radiation from the receptor, and beam restriction also decreases the number of photons striking the image receptor, so all of these decrease the amount of receptor exposure. Anode Hill effect absorbs some of the radiation coming through the thicker part of the anode, and that decreases receptor exposure. And anytime the patient's size is larger, there are more X-ray photons absorbed, and so there's less receptor exposure. And if we have additive pathology such as fluid or pneumonia, we would have decreased receptor exposure if we don't compensate. On the contrast side of things, as we look at the various things that affect contrast, basically KVP, as we increase KVP, the penetration is more even, and so things look all very similar gray, and so that tends to decrease the contrast. If we increase the OID, that removes scatter, and that increases contrast. So anytime we remove scatter, we'll have a contrast increase. Same thing happens with grid ratio. So as these two remove scatter, we have a increase in contrast. Beam restriction also removes scatter, and so that increases the contrast of the image. X-ray tube filtration, as we increase the aluminum in the filtration, the beam is hardened, and that's similar to the KVP increase, and so that would decrease contrast. And then as patient size increases, there's more scatter produced, and that decreases contrast. If the patient has an additive pathology, such as fluid or pneumonia or osteopetrosis, those areas will look whiter compared to their background, and so that's an increased contrast of that area. Spatial resolution is measured in line pairs per millimeter, and the things that affect spatial resolution are motion, and so as motion increases, there's more blur, and we have more blur if we have a longer exposure time. So as we increase the exposure time, we decrease spatial resolution. OID, as it increases, the penumbra size gets larger, and so spatial resolution goes down, whereas with SID, if we increase SID, the penumbra size gets smaller and spatial resolution goes up. Focal spot size, as that increases, the spatial resolution gets worse, and so that decreases spatial resolution. So those all three have to do with the geometric factors that affect spatial resolution. And again, motion increases. As we increase that, we have more blur, so less spatial resolution. Increased patient size tends to increase the OID, and so that decreases spatial resolution. Distortion is affected magnification more by geometric factors, and so as we increase the OID or increase the SID, we change magnification. And increasing OID increases magnification, increasing the SID decreases magnification, so those two are the geometric relationships for magnification. Patient size increase would increase the OID, and that would increase magnification as well. Shape distortion has to do more with the angle of the tube and the part in the receptor, and that is sometimes also affected by patient size, and so patient size and angulation affects distortion. Signal to noise ratio is going to increase whenever we increase the signal or decrease the noise by taking away scatter. And so when we increase MAS and KVP and the factors we mentioned that increase the signal, that would increase signal to noise ratio. OID removes some scatter, and so that's going to increase the signal to noise ratio. As we go up in SID, the signal decreases, and so that would decrease signal to noise ratio. And grid ratio takes away scatter, and that would increase then the signal to noise ratio by taking away scatter. Grid cutoff, however, removes primary radiation, decreases the signal, and tube filtration does the same thing. Beam restriction removes scatter, and so that would increase the signal to noise ratio. And then the patient size would increase scatter, and so that would decrease signal to noise ratio because it would increase the amount of noise. So just pay attention to the areas of change on this chart.